should be good. Resuming, my battery died. Roughly around the 4-hour mark is when the battery usually dies. Let me quickly reshare the link for those who are tracking this in Discord. Okay, we should be ready. Let me continue where I stopped. Again, the battery died, so I'm just resuming the stream. We were reading the pipeline breakdown. So samples a corpus as per sampling config and trains as SPM. We're gonna not do that. We're gonna reuse the SPM 200. We need to sample a corpus since training an SPM on all of the corpora is time consuming. This is done jointly for source target directions by default, but can be done separately as well. The trained SPM, the model file, and the vocab file are saved in the vocab bin directory. Then we do the dedupe sharding. The duplicates training corpora across the eval corpora and optionally across folds as per the dedupe config and shards training corpora. Okay, and finally binarization binarizes all the sharded files using multi-proc var sec binarizer encoder object and writes them to the sharded directories in the data bin. Caveat: this pipeline doesn't work if metadata is not specified for all corpora for a fold language directory, because we concatenate all corpora files for each fold direction into one file and then we shard them. Fair enough. So we need metadata information for every one of these lines is specified at all for the fold lang dir. Okay, makes sense. Let's continue. Why is this still running? So yeah, the issue here is some of these processes take a lot of time. But anyhow, we're gonna do that in the background while we are analyzing the prepare data script. We're finally there. We are now past the filtering stage almost. Let's see, batch number 4. Let's kick off another filtering batch. Again, for those of you who didn't see this, I'm basically batching my filtering pipeline so that we have 10 processes running in parallel to avoid some of the issues we previously hit, which I suspect had to do with the fact that we were running too many processes in parallel on a local machine. That's my understanding. Okay, prepare data. Let's find the prepare data script. Oh, this one was fast. This one was super fast. Again, it's very much batch dependent how fast these batches are processed. Let me find the prepare data file. Let me pin it here. And here it is. Here is where the main logic happens, inside of the run. And then we can kick it off. The default config is prepare data. I don't think we have any special launch JSON settings here. Okay, this one is also done. This might be interrupting us, which sucks, but I really need to babysit the filtering pipeline this first time, and then later we'll have more confidence. So let me just close down everything we don't need here. README, toxicity, all of this can be closed down. Utils, we can just close down all of that. Again, let me see whether I have prepare, nope, length factors, populate data config, filtering. I don't have any specific config, which means everything here is just specified directly in the prepare data config file itself. So we use it to initialize the prepare data object, and then we call run. As you can see here, we call async IO run, and then pipeline run. Okay, we'll be stepping through that. Let's quickly go through these settings. So here is how this looks like. Let's see where we can start. So the output directory is gonna be prepare data, output data. Let me create something like processed data directory. That's going to be our output directory. We're going to set partition to null, which means we're running locally. That's all fine. And now we have to, as you can see here, this corpora has to be in a particular format. And because we'll have a ton of directions for train, we need to again modify this so that it takes in a path to a config that has all of these particular directions, right? And we have to set that automatically. So that's what I'm going to do. I'm going to now write a script that's going to create this type of config for us. And then we're going to just link here a path. That's going to be my first step. And then later we can analyze all of these. Let me know if that makes sense. So let us see, what do we want to do here? So we pass in a file. These files are going to be, we're going to be reusing the filtered files. Okay. Let's create a file called prepare configs 5. Again, the output of this one is similar in a way to the output of the one we used for filtering. Let's find the extract directions, this one. I'm gonna copy paste that one, just start from there. So paste it here. I think it's going to have 3 additional files: train, corpora, validation corpora, because those are the ones we have to pass in here. Valid, train, and potentially test, or maybe train and valid. Let's see. Train corpora and valid corpora YAML. That will contain filtered datasets from the filtering pipeline stage. The purpose is to make prepare data YAML config more readable and easier to maintain instead of dumping this information directly into prepare data YAML config. We instead link paths to YAML files. Okay, that's roughly the explanation. So here we're using pathlib. Previously we were using OS path. So let's dump these files directly under conf here. Although that might be misleading. No, I'm gonna just dump it directly here. Like this. And just parent. That's it. This is just going to be the root path. And then we do what? We open... No, we actually need to now iterate through the filter data. So we need to iterate through the filtered data, which is going to be dumped here. Copy path. Filtered data root path is going to be this. I'll later refactor this so that it's not that tacky. We don't want to hard code my local environment path. So next up, we have to iterate through these configs. Sorry, through this output of the filtering stage. We go through all of the directories, and then we grab all of the directions here. And then we grab the actual files. Okay. So let's build up this config. I'm just gonna leave a single, these two lines here because I'll be reusing something similar. So let's iterate through this one. And again, let's just see quickly, what do we expect? We need to have train, so language direction, followed by dataset name, followed by source and target. This looks exactly the same as what we had in train primary config, right? This is roughly the same thing, minus the all of these other fields. So what we can do instead is we can leverage the train primary, delete these fields, and modify these paths. I think that's going to be a better approach. So let us just copy this. Config path is going to be this one. We'll open config path. We'll load the config. And we just modify it a bit. And that's everything that we'll need. So we'll be going through the config and removing some keys. So let me think. Let's go through this config. So for directioning config keys, okay, we're done with the next batch. Let me kick off yet another batch. This is again filtering stage, we're babysitting it. Okay, this looks good. Let's just print this. We don't want to do this. We want to, let's just print this guy, or just assign it to a temporary variable and then print it, because that's a variable we'll want to modify, right? And once we modify this config, we're gonna dump it to the parent here. So we're gonna dump it to here. And we're gonna call this one train corpora YAML, and we grab the config and we dump the config there. Now here we have to do some processing. To do remove unnecessary keys and modify source target paths so that they point to filtered data instead, right? Okay, let's kick this off. Let me change a different config JSON and then kick it off. Okay, here we are. We read the config, we go through directions, and then we go through corpuses, corpora, or however you say that in plural. And then we grab this object, and what is this? Is this a dictionary? That's the question. What's this? This is a dictionary. Okay, so from that dictionary, we want to remove everything other than source and target. How does one remove keys? Do I just do delete? How does one remove keys in Python? Python remove keys from dictionary. Free code camp. Okay, so we literally call delete. What's the second option? Pop. Okay. So what we can do is do delete, not source, that's like the only thing we don't want to delete. Instead, we want to delete TSV, metadata, fold. Again, we want to delete fold, language there, fold, language direction, metadata, and TSV. That's one thing we want to do. Original data. And then we need to modify the paths. Okay. Let's call this one dataset. Okay. And now let's modify the paths. If we how can we do this? Do we want to modify the filter out? Do we want to post-process the outputs from the filtering stage so that we are flat again? And then, so we want to maybe just extract all of these on top and then go through those, or just create a dictionary. Okay, let's create a dictionary before we even start. So I'm gonna give it this path, and then we're gonna create a dictionary from here. So let's iterate, let's do OS walk. And keep on adding files. Okay, so we create a dictionary called BCP 47 for language direction to filtered data path. Okay, it's going to be initially empty. Next up, we iterate through the filter data. We'll have to import the OS, even though we have pathlib as well. Okay, and then what I want to do here is, if files exist, no, if your root is string primary, wait, just a second. So if the root is string primary, suffix, okay, we can ignore these. Just find the files that have valid suffixes. For file in files, suffix is this. If suffix in, now we have to have valid BCP codes. For that, we have to copy that from fairsec. So if the suffix is a valid code, which we're gonna grab from the fairsec code base, let's go to code mappings. Let's go to here are the valid codes. Can we somehow find that directly here as well in Stopes? Does Stopes has the, let me see, ACE Arab? Okay, it does have it here. ton of YAML files. We can ignore all of these. So let's just copy this. We just need this. And we need to put that here. BCP 47 codes, forwarded codes, and then if the suffix is in there, in that case, we enter and let's see whether this makes sense. No, it does not. We want to grab the parent dictionary, which is going to be root, and basically store that. Split and grab the last one. Just base name. And then with that direction, we pass in the join between file and root. This actually almost made sense. Copilot was almost correct. We don't need the lang. We can just delete this. And this should be enough. So basically, again, we go through the files from the filtering stage. If the file has the BCP 47 code, well, it will actually have GZ, so we have to count for that as well. We're almost there. Suffix is going to be actually then minus, not the last one, but the second to last one. This is going to be suffix. So if the suffix is supported, we grab the direction and we store the path. That's it. Now that we have this, now we can go here, use this new dictionary, and modify dataset TSV such that, again, we assert that direction is in supported codes. If that's the case, what we do is we map dataset source to something like this. There is one more thing we have to figure out here, but I think we're close. I think we're close. So direction we'll obviously have two files, so we have to count for that. Source and path. One is going to be the source, one is going to be the target, and that's going to depend on the name of the directory, right? So the first one is the source, and the second one is the target. That's the convention, the implicit convention we're using. So let me let's do something like this. Split, we get the source and target, and then direction. For that particular direction, we can append. We can always append and create a list. And then here, will that make it easier for us here? Let me think for a second. And then after this one, we're gonna do a quick break, guys. I need to go grab some lunch, and then we can continue a bit later. Ideally, we would do something like direction source. If source in file, then we add the source. Else if target in file, then we add this. Else raise exception. Okay. That means now we'll have to actually have here default dictionary, which means we have to from collections import default dictionary. And that's roughly how I think this should be done. Probably a more elegant solution can be provided, but this is good enough. And then down below, we grab direction and we grab the source. And we just go and grab the source here, and we grab the target here. So sometimes I'm using TGT, sometimes I'm using target. Let's see whether I'm consistent. I think I am. Okay, stop this. Let me stop this and let me rerun it. Let's rerun and see whether this logic makes sense. So we're walking through filtered data until we find the right suffix of the file. Then we grab the base name, which is going to be direction. We grab the source and the target. If this is in file, so file is AK Latin. So because this is the right one, we are going to, for that direction, for this particular language, we are going to add that file. And we're gonna keep on doing that for each of the files, okay? And then we open up our train YAML. Okay, for some reason, we just ended up here. What happened? Okay. This one is not supported. Because we are passing in direction, not the... Okay, let me just stop this. We actually need to assert this for source. And for target. Okay, that's how we need to do it. Let's rerun. Let's go. Split assert. Go through the direction. We get the corpus. We grab the dataset. We remove a couple of these unnecessary keys, and then we need to map. So this language, ACE Arab, English Latin, ACE Arab, now gets mapped to, we grab that direction above, and we grab that particular source. Let's see whether this makes sense. So this will return us back ACE Arab GZ, which is precisely what we need, right? It is giving us back for this direction For this direction, we might have multiple corpora. For this corpora, okay, I don't think we've done a good job because we have multiple corpora. I'm making some errors here. What happens if we have multiple? Can we have multiple outputs in a single filter config? Okay, guys, I'm gonna make a quick break, go grab a lunch, rest my brain a bit, and then come fresh to this assignment. I think I made a small mistake assuming that all of these will only have a single file, which will not necessarily be the case. For some of these directions, we might have more. For each of the data sets, we'll have multiple of these GZ files. So here, for example, here is an example. So this was the assumption. I kind of assume we only have 2 files. But here we have both for Tycho and for Horn MT. So I'll have to handle that as well. And then, but we are very close to handling it and getting the final config. I'll stop this now. And then we can continue, and hopefully the filtering is going to be done by then as well. Let me see, where is the filtering file? Here it is. Let's see how this one is progressing. Catch you after the break. Now is 3:30 p.m., which means I'm late. I should have started at 3:30 the second stream, but we kind of prolonged this first one. So let's say 4:15 is the next stream. Catch you then. That means in 45 minutes. See you then, guys.